Hi, welcome back. We are going to be working with section 13.3 today. 13.3 deals with the law of sines. And what the law of sines is going to do is it's going to allow us to use trig functions to solve problems that deal with not only right triangles, but acute triangles and other types of triangles as well, which is what we've had those previous sections. We've had to have right triangles every time. So our first example here is very basic. How do we find the area of this triangle? They've already given us the base and the height. So we should be able to calculate this using 1/2 base times height, our formula for area of a triangle. If we plug in our values, we get 1/2 times 20 times 12. And so we find that the area of this triangle ends up being 120 centimeters squared. We'll move into this next one. They ask us, how do we find the area of this triangle? We've got our base of 150 here they give us. And they tell us they have this angle measure of 40. We have the side length here is 100. And then this is a right angle, so AD is perpendicular to BC. So we need to find this height, because our area formula, again, 1/2 base times height. Well, the height actually can be found using our trig function, so sine of 40 equals the opposite over hypotenuse, so h over 100. If we multiply both sides by 100, these will cancel out, and we find that h, our height, equals 100 times the sine of 40. So let's go plug this in over here. Now we have our area is 1/2 base, which is 150, times 100 times the sine of 40. So let's pull up our calculator. I'm going to move it over here so we can see our equation. So our area is 0.5 times 150 times the sine of 40. Oops, sorry. Should be 100 times the sine of 40. And we get the area of this triangle to be 4,820.9. So I'll write this in here. Our area is 4,820. Gotta double check. 820.9 units squared. Okay, so we can use some of our trig functions to solve for the area of a triangle as well. And this is that same formula we just used. Area is 1/2 a times b. So I'll scroll down so we can see our picture here a little bit. Area is 1/2 a times b times the sine of c. And a and b are lengths of two sides, and c is the acute angle between them. And that's the important thing to recognize. This has to be the angle in between those two sides. So here's a and b. The lengths of our two sides are a and b, and c is this angle in between them. All right, so there's our formula and our triangle once more. And you can pause it if you need to write this down. So moving on, let's find the area of this triangle to 2 decimal points. Again, that formula was 1/2 a times b times the sine of c. So in this example, remember our angle c needs to be in between a and b. So here's our a value and our b, and 58 degrees is c. So let's plug these in. Our area should be 1/2 5 times 7 times the sine of 58. Pull up our calculator again. So 0.5 times 5 times 7 times the sine of 58. And we get the area of this triangle to be 14.8. So as you can see, we can use trig functions to help us find the area of triangles now. So I'd like you guys to work on this one as your own, so pause the video and find the area of this triangle to 2 decimal points. Okay, hopefully what we did is we used our area formula again that we just found So 1/2 A times B, sine of C. Our A and B are 7 and 12, so area equals 1/2 7 times 12 times the sine of 65. When we punch this into our calculators, I have to move this over to the other side now. We get 7 times 12 is 84, and then times 0.5, so there's our 1/2, and then times the sine of 65. So the area of this triangle is 38.06. So area is 38.06 centimeters squared. So now it asks us, how can we solve for the missing side and angles of this triangle? So we can't use sine, cosine, and tangent though, unfortunately, because we don't know if this is a right triangle, and we can't just assume it is. So here's a picture of our triangle. So is there any way that we know to solve for this? So you guys can take some time to think about it. If you want to pause the video. Hopefully you found out that we can't figure this out yet. There is no way for us to solve this missing triangle. What we need is that we need a new rule or formula to figure this out, and that's where the law of sine comes in. And what the law of sine says is that if we have an acute triangle and our angle measures are A, B, and C, capital A, B, and C, and side lengths are A, B, and C, with A opposite from angle A, side length B opposite from angle B, and side length C opposite from C, angle C, then sine of A over that side length A equals sine of B over side length B, and sine of C over side length C. So again, capital A and capital B and capital C are angle measures, and this little a, b, and c are side lengths. Okay. So there's our law of sines, and here's the picture of our triangle. So again, angle A and side length A are opposite each other. Angle side length B and angle B are opposite each other. And side length C and angle C are opposite to each other. So that is the law of sines. And we can say that each one of these are equal to each other. So let's try an example here. We'll go back to that example we just looked at, and let's find the missing sides and angles. So we have side length A here, and angle A, side length B, so let's find angle B that's opposite. So we should have the sine of 70 over side length A, which is 17, and we set that equal to, sine of B over side length B, which is 12. To solve this, we're going to cross multiply. So we get 12 times the sine of 70 equals 17 times the sine of B. Okay, so let's pull up our calculator and see what we get for 12 times the sine of 70. That's about 11.28. So now we're at 11.28 equals 17 times the sine of B. Okay? Next we can divide by 17 to solve for that sine of B. I'm going to pull up our calculator again. So 11.28, our answer for the last one, 11.27, I'm going to leave it unrounded. Divided by 17, and we get 0.6633. So back here, 0.6633 equals the sine of B. So since B is an angle measure, we're going to need to use our inverse trig functions. So I'm going to bring this all the way over here. So the sine inverse of 0.6633 equals our measure for angle B. And now I got to move my calculator. Move my calculator back over to the side. And we can do the sine inverse, so second sine of 0.6633. And we're going to get about 41.55 degrees. So angle B equals 41.55 degrees. Okay, so that's how we use law of sines to help solve for angle measures or for side lengths of triangles. So I'd like you to give this one a try. Find AC, so this length right here, to 2 decimal places. So using the law of sines. Go ahead. Okay, so hopefully you've had some time to find AC. Going through this one, we've got our angle A, and this is our side length A. We've got angle B, so this is side length B. So solving here, we have sine of angle A, which is 65, over 80, equals sine of angle B, which is 85, over angle B. Or sorry, side length B. Now I'm going to move this over here so I have some more room. But first, let's figure out what sine of 65, or excuse me, sine of 85 times 80 is, as we cross multiply here. So we have to do 80 times the sine of 85. And that's going to be 79.69. So 79.69 equals sine of 65 times b. So let's see what the sine of 65 is. Whoops, 64. 65, sorry. 0.906. So we have 79.69 equals 0.906 times b. So to find side length b, we need to divide this by 0.906 divided by 0.906. Moving this back over. 79.69 divided by 0.906. And we get that side length B, or AC, excuse me, to be 87.96. Okay? Moving on to the next one. Here they want us to find AC again to 2 decimal places. This time we have angle, or we have length AB here. So this would be side length C, but we don't have angle C. So the question is how can we find this angle to help us solve this problem? And we know 2 angles already are 25 and 115, so we should be able to do 180 minus 115 plus 25. And 115 plus 25 is 140. So this angle here should be 40 degrees. Now we have angle C and side length C, and they want us to find AC. So this is our side length B because it's opposite of angle B. So let's solve this one. We can say that sine of 40 over 43 equals the sine of 115 over B. Okay, so I'll give you some time to punch that in your calculators. So after we cross multiply here and solve this, we get sine of 40 times B equals, let's figure out what 43 times sine of 115 is. So 43 sine of 115. We get 38.97. So let me put my calculator away here. 38.97. So if we divide that by sine of 40, divided by sine of 40, we should get our length for B. So 38.97 divided by the sine of 40 is 60.62. Let's find a good spot for that. So side length B is 60.63 units. One last example. They want us to find angle F here to 2 decimal places. Okay? Here we have angle D and side length D. we have side length E, we don't have angle E, we don't have angle F, and we don't have side length F. So what I'd like you to do is take some time to finish this, or to start this problem, and give it a shot. So this is going to be a multi-step problem. We're going to have to do sine of D over side length D equal to the sine of E over side length E. And then once we find what this angle E is here, we can figure out angle F and then set up a law of sines with angle F and side length F. So let's start with this one. Our sine of D is sine of 99 over 19. This should be equal to sine of E over 9. Cross multiplying, we get 19 sine of E is equal to what the sine of 99 is times 9. So 8.89. And then lastly, we're going to divide by, or second to last, sorry, divide by 19. So 8.89 divided by 19. We get 0.4678. So the sine of E equals 0.4678. All right. Now we're working with angle measure, so we have to calculate the sine inverse of this. Sine inverse of 0.4678. We get that angle to be about 27.9 degrees. So again, this was angle E as 27.9 degrees. So we can calculate angle F. And let's do that right now. So 180 plus, or excuse me, minus 90. Sorry, 99 here, not 90. Minus 27.9. So this angle F should be 53.1. And now let's set up our second law of sines. Let's use sine of D, so sine of 99 over 19 equals sine of 53.1 over side length F. Cross multiplying, we should end up with sine of 99 times F equals 19 times the sine of 53.1. So 19 times the sine of 53.1. And we get 15.19. Divide that by the sine of 99. And side length F is going to be divided by the sine 15.38. So there it is. That's using the law of sine to solve for side lengths and for angle measures in non-right triangles. Here's your homework.